Hello friends, myself Manish Kumar and I'm going to discuss about a very important and new topic that is called end-to-end encryption, which is nowadays used by many service providers such as your WhatsApp, your Facebook and your video conferencing tool such as Skype and many other. So here the important point is what is an encryption and why it is needed. So one can see encryption is used to send the data from one end to another end through an open network or secure network. So it is very important when we transfer our data, it should be secured enough so that in channel no one is going to steal your data. If they steal also, they are not able to understand what exactly this data mean. So this is being done using an algorithm, right, which is a mathematical algorithm, cryptographical algorithm, or existing some algorithms which I am going to discuss. And there are so many platforms, as you can see, like messaging tools and email service providers are using this, and video conferencing tools as well as cloud servers are also using that end-to-end encryption. So as the word says RGB, R means red channel, G means green channel, B means blue channel. When we mix up all, then we are going to get a colored image. And image is just kind of a matrix, right, with real entries. The entries are between 0 to 255 if an image is 8-bit pixel, right. So what is an image encryption? So encryption is a method or an algorithm which change the data into an unreadable format. And why encryption is needed? Because of the fact that when we use a lot of devices to share our data from one end to another end, and so when we share our data, we need to be assured that the data is going to be secure, not to be transferred by some other way so that anyone can read your data. So there are many interesting fields where that image encryption can be seen, like military data and your of medical data and many more. So it has a vast application in the real life. And now we can discuss about the techniques of the image encryption. So here one can see the three categories. One is spatial domain, another one is frequency domain, and another one is the mix up of these two, that is called the third domain, as we will mix. So these three domains have their different applications and different role, which we will discuss into the new slides, right. So here one can see the structure of the encryption, how encryption works. So if you see here, key space, which provides coming from the key source, and encryption algorithm, which is a mathematical operations which converts the images, and a plain text is being provided to the algorithm along with the key, which will be shared through an secured channel, and since keys are very small, so which will be shared through the secure channel. And on the other side, receiver receives it with the key, he can decrypt the data. So in the middle, third party cannot able to read your data, such as adversaries. So this is called the end-to-end encryption. So let us have a look on existing algorithm on spatial domain. So here what basically happened is DNA encoding has been used, and XOR operation is used to transfer the data, and then outputs are listed here. One can see in a full detail about this encryption if you are more interested towards the spatial domain using this reference. One can see about the frequency domain using Fourier transform, fast Fourier transform, Fourier transform. One can see the encryption is being also obtained. But here the frequency domain will not give the perfect recovery. So there are several applications where we do not require the perfect recovery. So that is another application. And when we move to the mixed domain is a mixture of these two guys so that we get it into the desired outcome. One can see that here the original image was converted into HSV domain, and then after that we have applied a wavelet transform on it, and along with the permutations. So permutation comes from your special domain, and your wavelet comes from the frequency domain. So that is a mixture type of algorithm is being designed, and the reference one can see and understand how the work is going to be taken place. So the important part here is security and efficiency. One can see while proposing any algorithm, keep in your mind the security is as important aspect, and robustness is also important. So robustness provides the three fact. Here statistical test should be passed, key space should be large enough to resist brute force attack, and many other attack as well. And now efficiency. Once come to the efficiency, it should be running over the real time, as well as easy of implementation on the hardware part. There are some fact. Once if you see in this three figure, above figure A, B, C, you will see this red pixel, green pixel and blue pixels are scattered using a scattered plot. So here you see the positive correlation, and when the encrypted image, if you see, this is distributed randomly. So that is very important for any encryption algorithm to have it. Similarly, when you see the histogram analysis, original image in ABC, and encrypted image, you can find out D, E, F images, and then similarly G, H, I are decrypted image. So you look at it, D, E, F image, observe that all the levels of the histogram is constant. So attacker is not able to guess any information from the histogram, then histogram analysis is infeasible, here we can say. Thank you very much. Thank you for watching. Thanks a lot.